Today's chips are architecturally complex, often involving multiple different devices using multiple different materials integrated into one advanced package. The Infinity FA provides uniform delayering to expose large areas of interest while maintaining damage-free layer removal. Because of its low selectivity, it can be tuned to etch uniformly through layers and features comprising multiple different materials. The Secondary Ion Mass Spectrometry, or SIMS, module can detect the sputtering of a new layer or material in real time, stopping the etch process at the exact right point. This is critical when you cannot afford a failed delayering. No other etch process can match the speed and accuracy of the Infinity FA's Kaufman-type broad ion beam etch, or IBE, in whole-chip delayering. The Infinity FA provides a more capable and cost-effective solution than FIM for bulk material removal as well. Whole-chip delayering requires a process that is not only fast at etching the chip, but also does it accurately with minimal damage to the area of interest. The Infinity FA addresses all three of these requirements. For example, the Infinity FA offers high intrinsic uniformity, less than 0.1% variation across a 1 cm chip, which the Infinity FA achieves with its Kaufman-type broad ion beam source. Customers benefit because they are able to achieve whole chip delayering with better than 10 nanometer resolution after a 1 micron etch. The Infinity FA also offers minimal selectivity. That is, it etches at more or less the same rate no matter what the material, both because of the intrinsic low selectivity of its Kaufman ion beam source, but also because of the Infinity FA's tilting chuck that changes the angle of the etch. Support for RIBI and KB can reduce selectivity even more depending on the materials being etched. Because of its minimal selectivity, customers benefit from the Infinity FA's ability to maintain planarity while etching different materials with no smearing or trenching. The Infinity FA is a low-damage etch due to its low-energy ion source. This can avoid cracking ultra-low K dielectric layers. Because of this low-damage etch, customers benefit by being able to conduct an electrical test of a chip even after delayering. This will help DFFA customers as they design in test features to their latest devices. The Infinity FA offers precise endpoint control. Its optional SIMS package can monitor the signals as the layers are etched. Optical emissions can also be used to track progress during the etch, and its consistent etch rate also makes it possible to create repeatable time-based recipes. All these enable the Infinity FA to stop at the precise layer of interest. Using SIMS and the low power control of the Infinity FA at critical layers eliminates over-etching of thin 2 nanometer barrier layers. Another important key requirement is producing a planar surface. The highly uniform beam and minimal selectivity of the FA etch process consistently produces a planar surface, enabling high-resolution imaging across the entire chip. These are just a few benefits customers will see when using the Infinity FA for whole-chip delayering. There's no such thing as one-size-fits-all when it involves thin film and etch applications. The recent changes to the Infinity FA create a wide variety of different options, enabling customers to find the exact right mix of capabilities at the exact right price point. Rather than use its own specialized platform, the Infinity FA is now built using the same form factor as the recently redesigned Infinity Ion Beam Etch wafer etch system. There are several benefits to this change. It makes the Infinity FA platform easier to integrate with other Denton platforms. Using a standardized platform built around semiconductor-grade components also results in greater reliability. The standardized platform also makes the Infinity FA more easily extensible, and we are exploring adding additional capabilities and options to the Infinity FA in the future. Because it is now built around a standardized platform, the Infinity FA can now be tied directly into Denton's Bursa cluster system, enabling the creation of a fully integrated fab system with a built-in QA module, all without breaking vacuum. There are applications where the power of the RFICP source is not needed. The availability of a direct current DC source provides a lower-priced configuration of the Infinity FA. Both the RFICP and DC sources deliver the broad ion beam characteristic of the Infinity FA, but the RFICP will etch about 50% faster than the DC source. The RFICP is also capable of etching with oxygen, enabling reactive ion beam etch, which can minimize the selectivity of certain etch processes. ASM International's International Roadmap for Failure Analysis Solution Gaps report highlighted the emerging need for global IC delayering with material removal that can target a particular layer in a timely manner without introducing defects in the sample. The report specifically named Denton's Infinity FA as a near-term solution, with the long-term goal of having a completely automated process for removing and analyzing materials from large areas. For Denton, complete automation is a near-term goal. More on that in a bit.